Okay, so remember the Math Excel 8.6 is due tonight, and the 8.6 worksheet is due today. Tomorrow would be a good day in class to either work on like a classwork retake or just study more for your test. Okay, so the test is Friday. Okay, so on this one, by the way, all of these should look pretty familiar to what you've seen on your worksheets. This is going from P to K, and P is first, and K is second. Okay, so what I mean is this is a one-to-one, but P is where you start, and K is where you end up. So it looks like on this one, the best way to remember about this is K is at 3,6 and P is at 7,0. And a really big hint for this question is like if you split the middle between 3 and 7, you get 5. And that'd be your line of reflection. So on here, there's one choice only that has x equal 5. Remember when we've done the worksheet before on this one, it either said x equal 3 or x equal 2. So it's definitely going to be this choice. So we need to reflect across x equal 5 and translate. So the first step we should really do is the translate first. So we're trying to like go this direction. So 1, 2, 3. Hold on. Excuse me. This one. Sorry, we're going across x equal 5. So this would end up flipping this way. And then we'd have to go up. Oh, this is at 5, not 6. My bad. This is 3,5, not 3,6. So we're going to have to go up 5 units, and so we need a 0, 5 right there. So we basically have to go up 5 units and flip across the x equal 5. So up 5 units and then flip across x equal 5. All right, so there's number 1. The next one, identify all the lines of symmetry. So this one is a parallelogram that's not a rectangle, and that cannot have any lines of symmetry. So that's going to be D. It would have to be a rectangle. For 2, and it'd have to be a square for 4. So this one doesn't have any lines of symmetry. So it's none of your choices. The next part says what is the rotational symmetry, and it does match up corners. Like if you do your rotation 180, you'd make an X, and so this is going to be 180 degrees. So again, if you want to write this, for a rectangle, it would have to be like this, where you have one horizontal and one vertical. And again, for the square, vertical and horizontal, and then diagonals. But this is a different type of parallelogram that's tilted, and so it doesn't have any lines of symmetry. So now let's go on to number 3. Well, one way to tell is you can think about this being an obtuse angle and this being an acute angle. And that's how you'd know. So if it flipped, that's not going to work for choice A. Okay, number 3. On this one, you're going to do a glide reflection, reflecting across x equals 0. Remember, that'd be second, and the translate would be first, and this is going to be going down 1. So first off, remember x equals 0 is the same as the y-axis. And what I would recommend doing is choose E because it's far away. And that way it'd be very obvious as to whether it's right or not. So what we're going to do is see that E is at 3, -1. And we need to go down 1 first. And so that makes you go to 3, -2, because we're just adjusting our y-coordinate. And then when we reflect across this, we'd end up over here at -3, -2. So the E is going to have to be this one. This one's not low enough. And we knew it couldn't be A or D because of where the E is. Any questions? Okay. Again, this one you've seen before. You want to first go across line L, and then you go across line M. So it's going to look something like this. That's not perfect because it's, not spaced perfect. And then we go across M. And so what that ends up being is C. So what you need to remember about this, like in our notes, is reflecting across 2 parallel lines is like a translation. Reflecting across 2 parallel lines is like a translation. And so you're not going to choose the rotation ones. And then this part is a little bit technical, but I think it would help you understand it. If this distance between L and M is x, then from here to here would be a half x, and from here to here would be a half x. And so what you're doing is x plus a half x plus a half x, which ends up being x plus x, which is 2x. So that's why I always say twice the distance. So that's going to be C. So we don't know if this is 2 centimeters, 3 centimeters, or what, but then you got to double it because of a half there and a half there. So you want twice the distance. Okay, the next one, we have the x equals 0, which we know is the y-axis, and we have the 0, 6. Now on this one, we're starting with the double prime, and we want the pre-image, and so on this one we have to work backwards. So in other words, instead of going up 6, we've got to cross that out and go down 6. And again, choose a point far away, which in this case is the E. So the E double prime is negative 6, 4. So left 6. By the way, if it helps you, either use like a protractor or use a sheet of paper to draw this, if it helps you. Well, now I did that too low. 1, 2, 3. Yeah, it was higher. Goofed. Okay, so anyway, this is 4, and this is negative 6. Anyway, look for your coordinate, and then we want to go down 6 first, and so that means this needs to go to negative 6, negative 2, because you got to go 4 down and then 2 more to go down 6. And then we want to flip this way, and then we get 6 comma negative 2, and that's what we're going to want. So E is going to end up over here at 6, negative 2, so that's B. This one is in the wrong quadrant, and well, all the others are in the wrong quadrant. So basically find your point and then go down 6. So we went from 4 to negative 2, and then flip sideways, and so instead of a negative 6 we get a positive 6. Okay, so there's number 5. Number 6, this one we want to go across line 1, which is y equal x, and then second we want to do the other one. So when we think about our point, we've got negative 8, negative 7, and for line 1, what we do is we go y comma x, since it's y equal x. That's going to be the formula we use, and so that means go to negative 7, negative 8. So after our first reflection, we just switch the x and y's. Okay, and then the next one for line 2, this is y equal negative x. This formula would be negative y, negative x. So basically they have to switch signs. So this is where your negative 8 ends up going first, but we change it to positive 8 and change your negative 7 to positive 7. And so that's what we want to look for A prime. So that'd be this one. Now there is another point which is up here, which is probably 8, 7 to be honest, but the difference is this says B prime. And so you got to watch out for that. So just pay attention to which letter you're using. So if we need to do this, B was at negative 8, 0, And so your first step would be change it to 0, -8, and then change it back to 8, 0. And that's what this is. So it all does work out for both points. The next thing is, if like A is down low and A prime is up high, this draws a straight line and this one does too. And so if you're making an X, then it's a rotate 180. And this is going to be to the origin. To the origin and 180, because it makes an X. Okay, the next one says you have 2, 4, and it has the y-axis as the line of symmetry. So 2, 4 is there. Of course, the y-axis is vertical, and so you go over here to -2, 4. So that'd be if it's the y-axis. If it said the x-axis, then it'd be down here, which would be 2, -4. Remember when it redoes the worksheets, when I print different versions, it might change y-axis to x-axis, and it may change the numbers. So just pay attention to the details. Okay, the next one. So first we want to translate 1, 1, which means right 1 and up 1. And then second, we want to do y = x, which switches x and y. So again, take a point, or take a couple of points in this case, doesn't matter. D is at 4, 3. And after we do 1, 1, this makes you go to 5, 4. So we add 1 to our x and add 1 to our y. Then once we do that, we want to switch x and y, and so that goes to 4, 5. And so that's where your D prime should be. If we try another point, F is -2, -2. And so when we go right 1, up 1, this would go to -1, -1, which would actually stay the same because your -1's reverse. So this is going to be D, because the 4, 5 is the only one. This has E prime there instead of, and we want D prime to be 4, 5. All right, and then the next one says you have 2, 5, and it's y = x. So again, just switch them. So if it's 2, 5, then it's going to be 5, 2. So again, just do y, x. The next one has a composite figure. That means it's made up of more than one shape, and it has a semicircle, a rectangle, and a triangle. So think about this is the semicircle, and that's the triangle. Well, as far as lines of symmetry, it would have to just be this one line of symmetry, and so it's C. Because if you flipped it vertically, your circle wouldn't match up with the triangle. Same thing if you did the diagonals. So that's just going to be C with one line of symmetry. Now again, if you tried moving this point down and moving the whole figure around, it would not have rotational. It does not have rotational. It would not line up if it were rotated. Okay. The next one is y equal x minus 3 squared. And so to start with on this, on your calculator, you would add graph, and you don't have to change y to, well, you don't have to change f1 to y. We usually just leave it this way. And so we say x minus 3 squared, like that, and press enter. So it's going to look like this. Now, remember, you can do Control T to get to your table. And actually, exactly where the table is, it's lined up perfect for symmetry. And I'll write the table down and show you what I mean. So, a couple of quick notes. If it's minus, that means right. If it's plus, that means left. And so in this case, we want to go right. And remember, Control T for your table. And you have 1, 2, 3, 4, 5, and it goes 4, 1, 0, 1, 4. So in your table, sometimes you have to scroll up or down, but in this case it was perfect. You can tell that there'd be symmetry for your y values. The 1s would match up, the 4s would match up. Okay? And so at 3, 0 you have a point, and at 2, 1 and 4, 1, and at 1, 4 and 5, 4. The next thing is make sure you make a U, not a V. The V would be the absolute value function. And this one would be a parabola. So make it curve. Make sure you do the graph, because if you don't do the graph, that'd be half off. And then we would want the line symmetry to x equal 3. So in other words, if you have this line, which is x equal 3, it could flip over and match up. Any questions? Okay, the next one I know y'all have seen before. How many lines of symmetry does a rhombus have? 2, and it's only the horizontal and vertical. I'm just going to put H and V. Horizontal and vertical. Okay. And on our next one, we've got a rectangle. So again, it's only horizontal and vertical. So again, if it were a square, it would have 4. But this is a rectangle that's not a square because the length is longer than the width. So that's B. The next part is about the rotational symmetry. And again, if you make an X like that, then it'd be 180. Whoops, they already have the degree symbol. So again, if we refer back to the square, if it were a square, then it'd be 90 degrees. But it's a rectangle that's not a square, and so that's going to be 180. Okay, the next one, P and H match up. And because this has P on the left side of your statement, this has to be first and this has to be second. Even though they match up, this means that you're going to go left. And we can tell we're going to go left and flip. So this is the glide reflection with the minus 8, 0. So this one means go left, this one means go right. And so we don't want the go right. Okay, number 15. This time we're reflecting across M and L, and so again, first we do this, second we do that, just like it says. And so let's see, for L, this would look something like this, and for M, it would look something like this. And so that's going to be B. So here's just a little side note to help you. Reflecting across two intersecting lines. Reflecting across two intersecting lines is a rotation. So it's not the translation, so it's not A or D. The next thing you need to do is do your angle times 2. So if you do 76 times 2, you get 152. And so that's B. It's never the exact same angle. You got to double it. Reflecting across two intersecting lines, meaning two lines that cross, is a rotation. Okay, just like when we went across two parallel lines, that was a translation. So just a little extra note right there. Now this one, identify all the lines of symmetry. And first I'm counting the vertices. And since it has an odd number, then there's going to not be any lines of symmetry. Since it's odd, it's going to be no lines of symmetry. And then what you're going to do for this one is use your formula for your angle of rotation, 360 over n. And so this is 360 over 5, which is 72. Sort of reminds me of one you did on a worksheet where you had to divide by 7 and you got a decimal. But it's no lines of symmetry, and your angle in this case is 72. Okay. Next, find a congruence transformation that maps Z to D. So Z is first and D is second, and those correspond. So my thinking on this would be, does G go to T? And it does, because it'd be a 3 to a 3. So because of that, I just figured out it's going to be a reflect across the x-axis. So it's none of these others. we have to reflect across the x-axis because the G and the T are kind of close. So the G is only 3 units up and the T is only 3 units down. That's how I can tell it's going to be a reflect the x-axis. The next thing I have to do is we have to go left 4, and so that'd be -4, 0. If you want to write down your ordered pairs and figure it out, you can. I'm kind of pressed for time at the moment, so I'm going to just put it left 4 at -4, 0. Number 18. This one says verify the ASA postulate, and we know that E goes to H. And the first thing they're going to want to do is translate. And so you could just choose translate. And again, we know E and H coincide. So it's the same letters. The next thing they're going to do is rotate. So you can choose rotate, and we need HL to overlap with, okay, so H had 1 mark, L had 2, and so E has 1 mark and K has 2. So we're going to have to put EK right there. So this goes to EK, and then the last blank after all that sentence is it says triangle HLA, and that's in the same order as this, so we've got to put EKS. Okay. The next one, we're doing triangle EDC to MNP. So EDC is this one, and so this is first, and MNP is over here, that's second. So the first one is facing left, the other one's facing right, so I know it's going to be a reflection. And it doesn't look like you have to translate anything, so it's only a reflection, and the number is -0.5. Let's see if that makes sense. So this distance compared to this distance looks the same. They look the same size, and so that's going to be a reflection. You don't reflect and then flip for that one. So it's not a glide reflection and it's not a translation. Okay, number 20. This one, again, we want to go across the y-axis first, then the x-axis. And so if A is starting at 1, 4, and we're going across the y-axis, that'd be over here and go to -1, 4. And then we need to go across the x-axis next, and so that'd be down here, which is -1, -4. And that's what we call A prime. The next point we have is 5, 2. And so when we flip to this side, it'd be -5, 2. And then when we flip the x-axis, that'd be -5, -2. So we're going to want B because this point is -5, -2, and this point is -1, -4. Now when you're looking through your choices, if you look at where B prime is, it's probably also -1, -4, but we're looking for A prime to be at -1, -4. And so that's how we know it's not C. It has to be B. And then the next part, you make your X, and so that'd be a rotate 180 about the origin. Okay, then the last one. Again, y'all have seen the circle question before. This would have reflectional symmetry across any line passing through the center. So in other words, what that means is any diameter. And it would be through any angle. So you can rotate it any angle and cause it to rotate, and any diameter to reflect. Okay, so that's the end of the review.